Hey, good morning.
Good morning.
Okay, so today we're going to work on area models, but just to give a little background knowledge, we're going to go over area and decomposing numbers, which we already know about. So if we're doing area, what is the area of a rectangle? How would you figure it out?
The length times the width.
The length times the width. Good job, Callie. This one doesn't work. So if we're trying to find the length and width, or the area of a rectangle, it is length times width, right?
Mm-hmm.
Okay, so if we have 7 and 4, what would our area be?
28 square units.
Yeah, 28 would be our area. So the area is the length times the width. So if we're going to decompose a number, so say we want to decompose the number 28, how would we decompose it?
We would have 2 10s and 8 1s.
Yeah,
So
that's how it is. But just to keep it in numbers instead of using like manipulatives or something.
So you'd have 20 and 8.
20 plus 8.
Okay.
Would be how we would decompose. So why would we want to decompose a 2-digit number?
It makes it easier to multiply.
It makes it easier to multiply. Yes. Could we use this in addition, multiplication, any of those?
I think using all of it.
All of it. I agree.
It gives you nicer numbers.
Yes, friendlier numbers. We kept saying that earlier. It made a lot of sense. So, to do an area model, we are going to go over using manipulatives. So say we have the problem 21 times 8. You can do this with me if you would like. So to decompose, while y'all are doing that, just listen. To decompose 20, what would it be?
2 10s or 20.
20
Plus 1.
Plus 1. And 8, how would we do that?
Just 8. Would you put a 0 first, or do you not have to do that?
No, you do not have to do it. It wouldn't need to be. We know it's in the ones place. So we're gonna do manipulatives first. Already? Just I don't want to rush them. Okay, so we'll have, like we're doing an area, we're gonna have 21 up here. So our 21's gonna be up here, and 8's gonna be on this side. Because remember, we bring them together. 21 times 8 is ultimately what we're trying to figure out, right?
Right.
So we're going to use our manipulatives. We can all do this together to demonstrate 21, and we'll do 8. Good job, Callie. Like how you have it lined up in the corner. We're putting these on the outside of the line to show us that this is our model. So whenever we're figuring out our area, we're not going to count these because it's just the model.
Okay.
So we can fill in all of our spots. So can we fit 100s? Would we be able to fit 100 block right here? No. No, because if we do it, 8 times 20, that'll be our first thing that we're going to figure out. 8 times 20 won't give us more than 100. Or 8 times 2 won't give us more than 100. So we can start filling in.
Okay, so part of one hour time. Good job. Okay, so here's our order. So just put it to the side. And now today we're going to learn how to do multi-digit with this area model. So can someone tell me some differences we would notice as far as face values? Which one? Multi-digit and multi-digit would have? Both, okay. But, okay, so they both have 10s and 1s. Okay, which one was,
So this is, top is 21.
Oh, thank you.
You're welcome.
1,
okay.
So it should start to look like mine.
If you were,
2,
to construct this like we just did, how many ones did you have?
Alright, so to make this more concrete, we can show that 20 times 8 is just our tens blocks, right?
Mm-hmm.
So what would that be, 20 times 8?
I'm gonna do this one for you, and you're just gonna watch, and then we're gonna work together, okay?
160.
160, so we can put that there just to kind of show us each section.
Okay.
Then this section right here, it would be 8 times what?
8 times 1? Or
1.
okay.
Because we have our 20, we separated, and our other digit was 1. So 8 times 1 gives us 8. So that's just to show each section. So
Okay.
now we're going to make it more abstract. So you can clear off the manipulatives. We're gonna make it a little more challenging by using two two-digit numbers rather than just one. Use it smaller if you don't use those. Okay, so we can go over this one together. So the first one that we're gonna do is 35 times 34. So you can just put it at the top.
So then, next
Okay, so how would we decompose? What would we do first? The first step.
Decompose your numbers.
Okay, so which one do you want to do first?
35.
Okay, where would you want to put it?
At the top.
At the top? Yeah.
You would do 30.
5. Good job, Taylor.
And then 30.
Next step.
And 4.
Yes, good job. Okay, so then what would be our next step? So we're bringing them all together. So we're going to do each box, and it's coming together to multiply. So
it'd be 30 times 30.
mm-hmm. Y'all can work together on this. I'll let y'all do it.
And then this one would be 30 and 5. 30 and 4 times 5. Okay.
So 3 times 3 is 900, and you add 2 zeros.
30 times 4, 50, 150.
120. 3 times 4 is
120,
and it's 40.
20.
Okay, so now what do you think would be the next step?
I think you would add up all of these numbers right here.
Why? Why do you think?
These are what you call partial products. So
Yes,
you
good
don't
job.
so you don't have, it's not your whole answer. This is
Yeah.
just part of it.
Yeah, it's like their area of each little square, and you want like all the squares together, so you would add them all together.
Yep, good job. So you can figure out that.
50, 20, 20, 0, 10,
1,190.
Yes, that is correct. Good job.
Yay.
Okay, so I will give y'all a problem to work on your own. We're going to do 31 times 23. We're going to do it on here first, then we're going to bring it into manipulatives.
Okay.
Actually, we can do our manipulatives first, then we can bring it back to concrete.
Okay.
So kind of the same thing, the same layout we had here.
So 31 times
23.
3. So that would be 30 plus 1 and 20 plus 3.
And if you notice, whenever we separate them like Taylor did right here, you know that you need 3 tens and 1 1. And the same thing's gonna happen over there. You need 2 tens and 3 ones.
Okay. 30 plus 1, 20 plus 3.
What do you think you could use instead of Taylor?
Ooh, I can use a big one.
Mm-hmm. You can use the hundreds instead of the tens. Do we count our model on the outside whenever we're adding it all up?
No.
And that was just a model.
Yep, just a model. Good job.
20.
So what can an area model be used for? Like, how would this be beneficial while we're doing this?
Like if I'm trying to figure out like how big my room is, maybe.
Yeah.
Or if you want to make a garden.
Yeah, that's a good one. So why is an area model easier than just trying to figure out 31 times 23? How does it make it easier?
I feel like they can see it.
Yeah, definitely.
It's more of like a visual than.
Definitely. Good observation. I want to push it over, but it'll be a little easier. Yeah, good thinking, Taylor, to separate those. That way you know what's your model and what is not.
And then need another 10. And
Great job. Good work.
if I were to fit it on that edge.
Mm-hmm. Okay, so now let's bring this, we can leave our model laid out, but let's bring it onto paper. We'll make it concrete so you can understand.
So let's see.
You have this correct, but I don't know if you would want to set it up the same way as your model.
Oh,
It
yeah.
might make a little more sense. It's, okay.
Let's see. 30, 20.
That's how another way you can go back and kind of check yourself if you're not sure if you did it right.
So to do it on paper, would you be able to do it on paper, or would you be able to use manipulatives during a test?
Next activity.
Do you think? Normally.
Just paper.
Just paper. So we can see it better on using manipulatives, but if we were taking a test and we wanted to find an easier way to multiply, we could use it on paper. We can draw our boxes out and go that way.
Okay, so let's flip over to our board here. So you don't use that to and if we did the same thing,
So 600.
we pulled two bars,
That's 90.
once again,
Good job, Taylor. Way to check your work. 13. So how could you check your work
like the one we did.
looking back over your manipulatives? Like comparing it?
You can maybe add them all up, like 1, 2, 3, 4, 5, 6. It's 600 plus 3, 6, 7, 8, 9, 10. So that's 700
Mm-hmm.
plus a 10 and 3, so that'd be 13. So 713.
Good job. So that tells you that your answer is correct. So we're going to do one more problem. It's 34 times 26, and we're going to do it just on our paper. If you want, you can turn it over to the back and just draw a new box.
Can I move this? Okay.
Three.
What's our number?
34 times 26.
So 30 times 4, 20, 6, 20, 6, 20 times 4,
We'll break it apart to decompose. We decompose the numbers, that way they can get the first one first and add them all together at the end, kind of like what we did on this part here.
80 plus 1, 80.
It gives them smaller numbers to work with.
We're at 884.
Good job. Try to check your work with one another. So now we're going to model it all together. So our problem is 34 times 26. So we can model it. And this time, after we model it, we're going to label each section. That way it matches up with this. With our concrete. Taylor, I saw you just counting those out. Instead of counting those out, what could you do?
I counted 4 across and 6 down, and that gave me 4 times 6, which is 24.
Good job. And if we look back to our concrete one, we notice that 4 times 6 gives us 24. Good job.
Okay.
Good job, Taylor. So what's your total?
884.
Okay, so let's see what Callie gets to compare.
What am I doing wrong?
It's 20 rather than one's 34
There
and
we
it's
go.
times 26.
Thank you. 3,600. Okay. And then
Taylor, can you kind of help her out with her next couple steps if she needs?
4 times 6?
Yes, because we did it right here. Okay. So that is 6, 12, 24. And then you can find your 30 by 6. 30 times 6. That's this right here. Yes.
Yeah, good job.
90. And then, nope, you did 612. There you go.
180. And then
Then you have your 20 by 4. 80. So 4, 8, 16, 17, 18, 6, 7, 8. There we go.
Okay, so can y'all work together to demonstrate this on to the manipulatives?
Okay. Let's use yours.
Okay, so this would be, we would have our big one, which is 600, would be all of our hundreds.
And how would you have gotten that?
As there's 6 100 blocks, and we did 30 by 20 because there's 6,
Times 20.
yeah, there's 30 across the top and 20 down the side.
Yeah, good job.
And I think this will be 20 times 4.
Yeah.
Because we have our 20 and then our 4. It'll be
Good
80.
job.
And then this one we have 4 little ones by 6 little ones, so that's 4 and 6 is 24.
6 times 30.
Which would be these, because we have 3 chunks of 6.
Yes.
Okay, so do you see how it relates back to the concrete model? Okay. Well, that's where we would stop, and then we would go on to the reflection questions. So how can the area model help us solve multiplication problems more easily in our head?
It lets you mentally like see the picture, so like it's not just like a bunch of numbers, especially for younger kids and they understand.
And you break them apart, so instead of looking at 34 and 26, like you're looking at 30 and 20, where they both end in 0, so they're easier to work with.
Friendly numbers.
And they understand that like the 6 is hundreds, so we have like 600s and not just 6 times.
You get to see that there's 100 little squares.
Right.